Operations with complex numbers, Algebra 2 trigonometry regions. In the previous video, we learned what imaginary numbers were. We learned how to do the square root of a negative number, and we learned about the powers of I, and we also learned that the majority of it can be done in our calculators if done properly. And you're going to realize that is the same for a lot of this stuff too. But let's take a look at this. First of all, the question says, express the sum of 2 minus the square root of negative 2 and negative 3 plus the square root of negative 16 in a plus bi form. Now, if you type that into your calculator, it's not going to work out for you. If you type in 2 minus the square root of negative 4 plus, because we're doing sum, negative 3 plus the square root of negative 16. If you type that into your calculator, it's just going to say error. But if we simplify these like we learned to in the previous lesson and make it 2 minus 2i plus negative 3 plus 4i, square root of negative 16 is 4i, and the square root of negative 4 is 2i. Now that we could type into our calculator, and will give us the answer. I don't have the calculator software on the computer I'm shooting this video on right now, so you'll have to forgive me for that. But you could just type that in as is, and it should get you the answer. However, we don't really need a calculator for this because it's pretty straightforward. I'm going to just combine my like terms. 2 plus negative 3 is negative 1, and negative 2i plus 4i is 2i. But that's what your calculator should say if you type this in. All right, how about this one? 3i times 1 minus I. Again, try typing it in as is and see if it works. It may not. But this is a distribution question. 3i times 1 is 3i, and 3i times negative I would be negative 3i squared. And then this would simplify down to plus 3, because I said the most important thing from yesterday was remembering that I squared is negative 1. So this is like saying negative 3 times negative 1, and that's why it's turning to a plus 3. Now, one thing I really want you to take away from this problem is notice that they keep mentioning this a plus bi form. This answer right here is not an a plus bi form. This would be bi plus a. So when you get an answer like this, you do need to write it in a plus bi form, meaning the thing in the front, your first term, has to be the number that doesn't have I. That would be your positive 3. And then the term second in the back is your I term. And so 3 plus 3i would be the appropriate final answer. All right, how about if we just multiply? So this is a distribution question here. Again, just type it in with parentheses and everything in your calculator. It should work for you, but let me explain how it works. So this is distribution or FOIL, as you know. 3 times 1 is 3. 3 times negative 3i is negative 9i. 2i times 1 is positive 2i. And positive 2i times negative 3i is negative 6i squared. This is 3. These combine to be negative 7i, and then negative 6i squared turns into plus 6. And that's really key to a lot of this, is that I squared isn't really just basically times negative 1 to that coefficient. 3 plus 6 is 9, and a minus 7i is it. And so I want to do one more. 2 plus 3i squared, again, just type it into your calculator, but I'm going to show you why it is what it is. So 2 plus 3i. And why do you think I'm taking the time to show you what it is if it's just simply type it into your calculator? Well, the reason why I'm taking the time to show you, as opposed to just typing into the calculator, is because there may be a couple of questions down the road and maybe in class tomorrow where the calculator won't do it for you. So it's good to understand the principles behind what's happening. But 90% of these problems are done for us in the calculator. So a little FOIL here. Or this is a binomial squared. We talked about there's a shortcut for that. Well, first let me do the FOIL part, and then maybe I'll do the shortcut. So 2 times 2 is 4. 2 times 3i is 6i. 3i times 2 is 6i. And 3i times 3i is positive 9i squared. That turns into a negative 9. Paired with the 4 in the front, that's going to give us the negative 5. And the 6i is going to give us the 12i, and that's an a plus bi form. Now, these are not conjugates, right? Because these signs are the same. If they were conjugates, then we'd have a positive 6i, negative 6i, and we'd end up with just a negative 5. but they're not conjugates. We will see that in the next video when we get to rationalizing denominators with powers of I, stuff like that. But real quick, let me mention the shortcut I was talking about before, that a binomial squared. Remember, you can square the 2 here, and that's going to give you the 4. Multiply these together is 6i, but double it, 12i, because we have 2 of them. And then square the last term, 3i squared is your minus 9, and then combine like terms to get there. So it's just kind of a mental shortcut for a binomial squared. But this is basically it. And again, you could just type this into your calculator, and it should give you this. But I did want to show you kind of where the answer is coming from and talk a little bit about the a plus bi form. Okay, so pretty short video today. See ya.